My name is Aishwarya Srinivasan, and I am working as a data scientist in IBM. And as a data scientist and as a huge follower of open source community, I am really excited to talk about PyTorch Lightning today. And we have Oleksii with us, who's been working in NVIDIA, and he's a researcher. He's a part of the NeMo team. It is a conversational AI open source toolbox which NVIDIA had recently launched, and we're going to talk to him about NeMo, about a couple of examples around that, and his experience in building NeMo and using PyTorch Lightning in the entire process. So, hi Oleksii, do you want to introduce yourself?
Hi everyone. Yes, my name is Oleksii. I'm an applied scientist working on NeMo team.
Great. So, Oleksii, we would really love to hear it from you about how you came up with NeMo and what was the motivation, what is NeMo all about, and probably like support it with some examples around it.
Okay, sure. I actually have a slide or two, so let me start sharing that. Okay, so what is NeMo? NeMo is a toolkit to democratize conversational AI, and it is doing this by providing users with neural modules, which you can think of as building blocks for conversational AI models. And it also has full models, which are complete architectures together with recipes for training and optimization. And we are also investing a lot of computational power into pre-training high-quality models using publicly available data. What we mean by conversational AI is basically speech recognition, natural language processing, and speech generation. So these are like exciting research areas in deep learning right now. Here is a conversational AI stack with NeMo. NeMo is based on PyTorch Lightning, so it's not only you can use NeMo and PyTorch Lightning together. NeMo is actually based on PyTorch Lightning, and Facebook's Hydra is another PyTorch ecosystem project that we are using. And you can think of NeMo as two things. We have a small core, like NeMo core, which provides common look and feel for all the models. And we have collections of building blocks and models for speech recognition, NLP, and ASR. So here, yeah, go ahead. So here is an example, right? So a module, you can take as a, say, token classifier model. So this is something you would use as a head in many NLP models. It's a regular PyTorch module, but we also add something that we call neural types to it. And researchers can use those modules to compose their bigger models like building blocks. And we provide various like encoders, decoders, language models, and so on. Another concept which is actually based on PyTorch Lightning is a NeMo model. And the NeMo model is a complete recipe. First of all, most of them come with pre-trained weights, which you can grab from NVIDIA NGC Cloud. Also, it not only contains model architecture, but because it is a PyTorch Lightning module, it also describes how training is done, how evaluation is done, what kind of optimizer is recommended for this model. And this is very important, especially for conversational AI models, where it is frequently the case that training, for example, is different from inference. Like you can have teacher forcing in training, but autoregressive inference. So those are details that are very important to sort of include together with the model. Mm-hmm. So because every NeMo model is a PyTorch Lightning module, you can use them easily with Lightning Trainer. So you can see that every model is a Lightning module. So you can just plug it into PyTorch Lightning Trainer and train on one GPU, on many GPUs. you can use mixed precision and like multi-node training. So the part I especially like about like how PyTorch Lightning is done is that it's very seamless to go from like training on one GPU to training on like a supercomputer with like thousands of GPU and many nodes.
Wow, that's amazing. So, Oleksii, we wanted to talk about like how PyTorch Lightning has helped you as a researcher. You guys do a lot of model formulation, a lot of brainstorming on building ensemble models, and it sometimes does pose a challenge because a data scientist myself, I feel it very challenging to program all the models because a lot of the syntax or a lot of these programming frameworks are really bulky, and it takes you a lot of time to understand and wrap your head around these bulky programming languages, right? So how has your experience been with PyTorch Lightning? How easy was it for you to build your models and tweak them and do the multiple iterations of modeling on PyTorch Lightning?
Right. Great question. I think one of the sort of killer feature of PyTorch Lightning for us is that I think it's very naturally separates sort of science from engineering. And more specifically, like I said, every NeMo model is a PyTorch Lightning module. So if you are a researcher, who wants to develop a new, say, speech recognition model, so what you will be focusing on is describing your architecture, describing algorithmically how training step is done, how validation or inference step is done, how optimizer is done.
Mhm.
What you are not focusing because you are using PyTorch Lightning, what you don't need to focus on is how mixed precision is done, how multi-GPU training is done, how multi-node training. So those are very interesting, but let's call this like system engineering aspects.
Exactly. Yeah,
You don't need to focus on this. You just, as a researcher, you just focus on the model itself.
Yeah.
And once you verify that it works in a simple setting, you can just run it on the supercomputer then.
Yeah, absolutely. I totally agree with your point on reiterating over system engineering. I absolutely agree with that. So I wanted to know from you, like, what are the different kinds of algorithms have you worked on apart from like building NLP models for NeMo? What were the other use cases that you tried using PyTorch Lightning for?
So part of NLP, NeMo also contains collections of models and modules for speech recognition, speaker diarization, speaker identification, voice command detection, voice activity detection, all sorts of models for speech synthesis, spectrogram generators, neural vocoders. So those are all kinds of models we include in NeMo, and they are all based on PyTorch Lightning module. And we also experiment with different optimization algorithms. Like our team at NVIDIA released like a Novograd optimizer. So again, it's very easy to plug in your own optimizer if you came up with a different optimization algorithm.
Wow, that's really interesting. So, what would be your like biggest takeaway in using like PyTorch Lightning or like in NLP models or in your deep neural networks? So, what is your biggest takeaway as a researcher or as a data scientist, as a computer scientist? What is your main advantage which you found using PyTorch Lightning?
My main advantage for using PyTorch Lightning, I think, is that it sort of learned. Not. I think PyTorch Lightning team sort of learned all the good practices people were kind of using before, but sort of formalized them in the concept of Lightning module and trainer. Actually, before in an older NeMo version, we had where we were not using PyTorch Lightning, right? So we had our own analog of trainer called like Neural Factory. We don't have that anymore. But my point is that in this deep learning practice, there is a set of standard practices people tend to follow, and PyTorch Lightning, I think, did a great job in formalizing them and like organizing them so that it's much easier to follow, and it basically takes away a lot of engineering burden from researchers.
That's really great. I am actually really glad to see that an open source framework is really helpful in integrating into, like a huge organization like NVIDIA. So it's really very fascinating for me. And uh, thank you so much, Oleksii, for taking out time for this. And I really learned a lot. I hope like everyone who's watching us learned a lot from this session. And so what's the best way if like anyone had to like put you some questions or they had any feedback? So what would be the best way to contact you?
Oh, the best way to contact NeMo team is via GitHub. So NeMo is open source on NVIDIA GitHub, and it's not just open source. We actually do development in the open. We accept external contributors. By the way, we had a good model contributed by PyTorch Lightning team as well already. Yeah, so if you want to raise an issue on GitHub or send a pull request to us, we will be happy to have a look at it.
Great, thank you. This has been a great chat. Thank you so much, Oleksii.
Thank you for having me.